Hey everybody, and welcome to Chapter 9, and I've hinted at this earlier in the semester, but I think that Chapter 9 is one of the more challenging chapters that we're going to have all semester. So I'm going to try to record this all in one video, so I will let you know when it would probably be good ideas to take breaks and things like that, because jumping into this all in one video might be a little bit of an information overload. So yeah, we'll take it slowly. So what this chapter is, basically, what a factorial design is a fancy way of saying that you have research that is complicated. And specifically what that means is that you have an experiment that has usually two or more levels of the independent variable. And so sometimes that means you might have more than one independent variable, or it may mean that you have different levels of one independent variable. We'll look at the different kinds of that here. So we're going to be talking about advanced experimental design, and we'll be talking about interactions and main effects. So so you may remember last video we talked a lot about experiments, both between groups and within groups or within subjects. Now, if you're feeling shaky with that, if you are feeling a little bit like you're not super confident in that material, definitely go back and watch that video before you tackle this one, because this is just building up on everything that we just talked about. So if you don't have a firm grasp of the last chapter, this one is going to be really tough. All right, so whenever we are doing research, sometimes we are going to have more than one independent variable. And the reasons for that, sometimes it's by necessity, we have to have more than one independent variable. Sometimes it's that we feel like we have enough resources to do research that has more than one independent variable. Ideally, to be completely honest, it would probably be best if we mostly, as much as possible, used one independent variable. But you're going to see there's lots of cases where we need more than one. So simple experiments have one independent variable, and the nice things about that, the reason why I say that it's kind of preferable in most cases, is because whenever you look at your results, you can look at your independent variable and determine basic causality, right? That by turning on this condition, by forming these groups, you can tell that it had an impact on behavior, okay? So if the results didn't change between groups or didn't change between conditions, then you can probably assume that that independent variable didn't work, or that it didn't control behavior, that it didn't change behavior in any way. So factorial designs, on the other hand, are going to be a little bit tricky, because it's basically going to be that you have now more than one independent variable. And that makes things a little bit harder for us to understand discerning causality, because basically what it means is that it could be this independent variable that's changing behavior, it could be this independent variable that's changing your results, or it could be both together interacting. So this video in this chapter is all about these three different kinds of outcomes. So we have to set up these a little bit differently. And we'll also need to use different statistics to look at these effects. We're going to go into that more at the very end of the semester when we start looking at different pieces of statistics and testing and things like that. But basically, it's just more complicated. All right, so I'm going to give you, just like last chapter, I like kind of going through examples first. These are not the same examples that are in the book. That's by design. I hope that whenever you're reading the book, you'll see those examples and have just kind of, different context for all of this information. So here is an example. Let's say that you are interested in drivers. And particularly you're interested in whether or not people with cell phones are good drivers. But you hypothesize that not only are people not super good driving with cell phones, but you also suspect that age matters too. You also suspect that people who are older are going to be disproportionately worse than people who are young when they are driving with their cell phones. So that's your theory. That is your hypothesis. If someone is old and driving with a cell phone, then their performance will be worse than someone who is young with a cell phone, or someone who is old without a cell phone. You get the idea. There's lots of different kinds of information we can tease out of that simple idea. So if we're looking at what kinds of independent variables that we have, first we got groups, right? We're going to be grouping these participants based on their age, old and young. So we have two groups. That's one independent variable. But we also are going to give them a second independent variable, which is going to be cell phone use. We're going to have some of them use a cell phone and some of them not use a cell phone. So the basic setup in this particular experiment that we're going to look at, they had people come into a driving simulator, and basically all they have to do is follow a car. So they are in this really cool driving simulator that has these different screens. They got a steering wheel, and basically what they're doing is just following a car. And the task is to follow kind of as closely as you can, but to pay attention because this car is going to brake unexpectedly. It's going to slam on brakes for no reason. So what you're supposed to do is just follow, right? And we're going to see how long it takes you, the participant, how long it takes you to hit those brakes. All right. So the methods that we have here, as I mentioned, we have a couple of different independent variables. We have groups, right? And the groups are an independent variable. So we have old versus young. So participants were put into this. Now, this, even though we are forming groups, remember this is a quasi-experimental variable because we are not able to directly manipulate how old someone is, right? So this is already kind of a complicated factorial design, right? That we already have groups that are decided based on someone's age, but that is one variable that we are looking at. And then we're looking at a second variable, which is going to be cell phone, and we can manipulate that one directly, right? We can give someone a cell phone or not give them a cell phone while they are in the driving simulator. And so the dependent variable, the outcome variable, is going to be essentially how quickly someone is able to brake. Someone is able to hit the brakes. And we are under the assumption that the faster that someone hits the brakes, the better their reaction time, which probably means the more closely they're paying attention, the better driving they are doing. You get the idea. Someone who hits the brakes soon is going to be driving better than someone who does not hit the brakes soon, someone who takes a long time to hit the brakes. So, it can be really helpful to diagram this stuff out. When you're reading this in the book, you'll see that they have this kind of like one of the first things they talk about is charting this stuff out and coming up with a graphic representation of this. So we have here, I think you can see my mouse. We have groups and we have the independent variable that are assigned. And so what we are essentially doing is we're coming with 4 different circumstances. So we have young drivers that are on cell phones, and we have old drivers that are on cell phones. But we also have young drivers that are not on cell phones and old drivers who are not on cell phones. All right, so we have that right there. This, what you see in the green, this matrix is a 2x2. You'll hear this referred to a lot as a 2x2 factorial design. What that means is that you have 2 independent variables that both have 2 levels. Now, if we wanted to get complicated, and we will later in this video, we could show off. We could try to flex, and we could say, all right, actually we want not just old and young, we also want young, middle-aged, and old drivers. That would be a 2x3 factorial design because we have 2 versions of one independent variable and then 3 versions of another. But we'll get to that later. So for now, we're looking at this 2x2 factorial design, and you can see the 4 different kinds of circumstances that come out of using these 2 independent variables. So here are the data for this particular study. And this is part of the reason why sometimes it can be a good idea to kind of chart this out in a table, because It makes it a little bit easier to read sometimes. Some people like this more. I honestly like graphing it out. So I'm going to pull up the graph right here too. So if we're looking at this, we can look and say, okay, what are the results that young drivers on a cell phone, it took them 912 milliseconds to hit the brakes. Old drivers that are on cell phones took over a second to brake. So it took them 1,086 milliseconds to brake. And then you can see that whenever you're not on a cell phone, both groups were faster, right? So 780 milliseconds versus 912 milliseconds. So there's a lot of data to unpack here, right? If we were just doing comparisons, we would say like, all right, when people are on cell phones, if you're older, you're slower than when you're younger. But also, whenever you're not on a cell phone, that younger folks are faster than older folks who are braking. But we also see that if we're just looking at younger folks, the younger folks, whenever they are on the cell phone, are going to be slower than when they're not, and the same is true for older drivers. Okay, cool. Lots of data here to unpack, lots of data to talk about. And you can kind of see that graphed out right here. This is what we are going to call, and I'm getting a little bit ahead of myself, this is what we're going to call a main effect. In other words, we see that there is a main effect of cell phone, that this condition changes the results on its own. So whenever someone is on a cell phone, you get the results. When you take them off the cell phone, you can see that the results across the board change. So it unilaterally changes. Everybody gets faster whenever you take away the cell phone. All right, so let's look at the data from this particular study. This is a 2001 study, so it's almost 20 years old. Basically, faster brake times whenever you are not on a cell phone, and faster brake times when you are a younger driver. Both of these are called main effects. We would describe this as a main effect of cell phone condition, but also a main effect of age. We see that for everyone, that in both conditions, you're faster whenever you're younger compared to whenever you're older. So that is the results for that study. We're going to revisit some of these ideas later, but for now, I want to give you one more example. This particular example is using alcohol and aggression, and so the researchers here are interested in whether or not alcohol makes people more aggressive. This one is a little bit of a tricky kind of experiment, but it's a real experiment. So what they did in this case is they gave participants either orange juice or orange juice with vodka in it. In both cases, they're getting kind of this, this kind of sour drink, it's acidic, it's orange juice. And they split the groups up between people who are lightweight and people who are heavyweight. And I don't mean that in terms of drinking tolerance, I just mean that in terms of body mass. So you have people that are going to get alcohol and people who are not going to get alcohol, which is the true independent variable. You can directly manipulate that. And then we're going to split them up into this quasi-independent variable, this quasi-experimental variable, which is going to be body size, so light versus heavy. And then they're going to ask to punish players whenever they get a question wrong in a trivia task. No one's actually getting shocked. They were just told that they are going to be shocking people. They were basically, the researchers were going to see how hard or how what is the phrase? How strong a shock someone is going to administer whenever someone is getting an incorrect answer. So if you were in this experiment, basically you would be given one of these drinks, then you would be asked to, okay, we want you to deliver a shock to this person whenever they provide an incorrect answer. That's all. It sounds a little bit like Milgram's study on obedience. It's very different, but you get the idea if you're familiar with that study. So the researchers were interested in how hard or what the strength of the shock is going to be for the other player, with the assumption then being that someone who administers a really heavy shock is going to be more aggressive than someone who administers a very light shock or a very soft shock. All right, so the methodology here, again, if I were to give you something like this on an exam, I would want you to identify the independent and dependent variables. So let's take a look. What are they? The independent variables in this case is going to be the alcohol, whether you had the alcohol and vodka, or just the orange juice. Sorry, I got that wrong. I said that wrong. Whether or not you got the orange juice or the orange juice and the vodka. The other independent variable, the quasi-experimental one though, is going to be light versus heavy people. So split up into two groups for that. The dependent variable, the one that's being recorded, the one that we are going to be comparing across these conditions, is going to be how aggressive are they. So what is the magnitude of the shock that people have administered to others? All right, so let's take a look at, and also, actually, before I get to this, if you were to chart this out, you could do this exactly like with the previous study. This would be a 2x2 design, right, where you have two levels of the independent variable, and we have two independent variables. So you could chart this out and look at these four different conditions, or four different contexts, four different possibilities where you could be assigned alcohol and be light, or alcohol and be heavy, or no alcohol and be light, and no alcohol and be heavy. All right, so in the results here, this is where things get complicated. So last example was pretty straightforward. It was pretty easy. This one is a little bit trickier to interpret. So here we're looking at this figure, and being able to interpret these figures is really, really important. I'll probably be giving you examples like this on the exam and asking you, is this a main effect or is this an interaction? In this case, we have an interaction. So what does that mean? An interaction is basically you interpreting the data using the phrase, it depends. So what does that mean? Basically, if I were to ask you straight up, does alcohol make people aggressive? You were to look at this data and you would say, well, it depends. What we're going to say here is it depends. Was this person, were they light or were they heavy? Because that is going to change the data. So let's take a quick look at this. What we're looking at here at this particular figure, on the y-axis, we have the shock intensity, where upper values up here are stronger shocks. And then we have here on the x-axis light versus heavy men. So what we're seeing here is a kind of a story going on. All right, if we just look at the placebo group, we're just looking at the placebo group right here, and we can see that, does it look like shock intensity changes whenever you are light versus heavy? Not really. It stays about at 5, right? But if we look at whenever people are drinking, does it change whenever you are light versus heavy? Yeah, it does actually, right? That it seems to be whenever you are less heavy that you're going to administer a shock around a 6, but when you are heavy, that shock is now more like a 7. But that's weird, right? We probably wouldn't have expected that. There would be differences based on light versus heavy individuals, but it also depends on whether they were drinking or not, right? So whenever they are not drinking, there is no difference between these groups. But when they are drinking, there is a difference between these groups. That is a interaction. In other words, if we were to look at whether or not there was a main effect, whether or not one of these variables changed the dependent variable, it's hard to say, right? It looks like, yes, whenever people are drinking, that they are more aggressive. But it depends. It depends on how intense that shock is going to depend on whether they were light versus heavy. And so if you were to graph this out, looking at diagramming it, basically this is the exact same information, just kind of presented in a slightly different way, where instead of having the colored lines here, we're taking these colored lines up here and putting them on the x-axis, taking stuff on the x-axis and putting it as the lines here. And you can see that pretty much for placebo groups, there's not really a difference between light versus heavy individuals, but there is a difference whenever those individuals had been drinking. So the OJ only group was more passive, they were less aggressive, and and heavier men were aggressive, but only whenever they were drunk. All right, like I said, that's a little bit complicated, right? So this interaction here is, like I said, I like to think of this as a "it depends" phrase, that like the data depend on the way that you break it out. Sometimes other people call this the difference within a difference. So we do see difference, but only at certain independent variables and not at others. That makes things more complicated. It makes them harder to explain. But sometimes that's necessary. These kind of interactions are important. If we'd only studied light individuals, for example, we might not see these dramatic effects, right? Having these two independent variables in is going to tell us something about not only drinking, but also body mass and how it affects our levels of aggression. All right, so this is a good part, and this is a good spot to pause it, to go get a drink, come back and finish this later. So if you want to pause it and go about your day, go for it. All right, so I trust that you gave yourself a little bit of a break, a little bit of an intermission. So we're going to look through one more example here. This one is a completely different task, but kind of interested in the same information, whether or not alcohol makes someone more aggressive. So maybe measuring shocks and how much you shock someone is not the best way to look at alcohol and aggression. There's other ways to do this. This is a little bit now more of a cognitive design, where we are going to look at what levels in which alcohol is associated with thoughts of aggression. So whenever people are thinking about alcohol, are they thinking about aggressive behaviors? So studying similar ideas, but in a very different way, right? So in this particular experiment, what happened is people came in, they enrolled in a computerized test where they're essentially asked, how quickly can you respond to these particular items? So the instructions are pretty simple. You just have to discern whether or not this is a word or a fake word. So if I were to show you the word hallow, you would say, yes, that is a word. If I were to show you the word PSYC, you would say, no, that is not a word. All right, you get the idea. So some of these words are going to be neutral. So like the word hallow is pretty neutral, but some of them are going to be a little bit more charged with kind of aggressive meaning, like the word fury or murder or violence or stab. You get the idea that these words, they are words, yes, but they also have a particular association with aggressive acts. So, before each of so that's one independent variable where we're looking at some of these words that are neutral and some of them that are aggressive, right? But we're also going to have another independent variable, which is before we show these words, we are going to show them a photo very, very quickly. And in these cases, these photos are either going to be of a plant or of an alcoholic beverage. So if you haven't taken cognitive psychology, if you haven't learned about this stuff, this is what's called priming. The idea that what the research shows, in these cases, is that whenever someone is shown something like alcohol, they're going to be faster at responding to words that are associated with alcohol than if you were to show them something that was unrelated. So the idea, kind of the theoretical background for this particular experiment, is that if aggression and alcohol are linked, that whenever you show someone an alcoholic drink right before they make a decision right here, they should be faster at replying towards these aggressively charged words than whenever you show them a plant, for example. So, just thinking out loud here, what are we expecting? We are expecting, in this case, an interaction. Why? And honestly, sometimes it's best to, I find it best, to draw this stuff out. Drawing this stuff out helps me organize my thoughts. So This is going to be an interaction. Why? Because if you're imagining graphing out your expectations for this data, we are looking at how quickly can someone respond to this, right? So we're going to expect that people are going to maybe respond a little bit faster to aggressive words compared to neutral words. But whenever we show them an alcoholic drink, we're going to expect that they respond much faster than when we show them a neutral word. Or sorry, a neutral photo, like a plant. So we're not expecting any difference for neutral and aggressive when we show them plants, really, but we are expecting a difference when we show them an alcoholic drink. That is an interaction. All right, so let's look at the different kinds of variables that we have here. I have already walked through this a little bit. The independent variables are going to be the neutral versus aggressive words, and also the photo that is shown before at the very beginning of the experiment. The outcome variable is going to be essentially how quickly they respond, the reaction time in this particular task. So here is the 2x2 table. So even though we're not making groups this time, this is an actual experimental design where we have two independent variables that we can manipulate in both. We can see that there are 4 different circumstances that we can show an alcoholic photo and then have them discern, an aggressive word versus a non-word. We can have an alcoholic photo and then a neutral word versus a non-word. We can have a plant photo and an aggressive word versus a non-word, and a plant photo and a neutral word versus a non-word. Okay, so those are the 4 different kind of contexts, and if you wanted to, you could go ahead and populate this to try to imagine what kind of differences there might be. And if you were to just eyeball this, for me, I don't see a huge difference that sticks out, right? This doesn't look like a huge difference. That's why I feel like it's best to plot this stuff out, to make it into a figure. That always helps show this for me. And so this is what we find. This is clearly an interaction. I'm going to let you in onto a little bit of a secret. I wasn't taught this in undergraduate, but I was taught this in graduate school. That whenever you see a chart like this, if you see the data following the same trend, like if the data, whenever they are in these lines, if they are parallel lines, that is almost always a main effect. If you see something like this, where they either intersect or come close to intersecting, that is going to be an interaction. So, why is that an interaction? Let's take a look. So, what we're seeing here, based on this data, is that whenever someone has an alcoholic photo presented beforehand, that they are much faster at aggressive words than neutral words. But we also find that whenever someone has a plant photo, that they are faster than for neutral words than they are for alcoholic words. Are these huge differences? No, not really, right? We're looking at milliseconds, and we see that this is a very, very small change, right? Maybe a 10 millisecond advantage whenever you see the alcoholic photo first. But it is a reliable finding, and it just shows kind of how quickly our thoughts occur. So this is an interaction. Now let's kind of drill down on the differences between main effects and interactions, and I'm going to kind of go through this piece a little bit fast just because I've kind of talked about main effects and interaction throughout this entire video. But if you were to look for a main effect, you can do that in a table. Excuse me. You can do that in a table like this, but I will admit it is kind of hard compared to whenever you're doing it with a figure, which is why I, again, recommend plotting this stuff out, drawing it out on sheet paper or whatever. So, I got the hiccups for some reason. So if we are looking at, I got these hiccups. I guess because I was talking about alcohol, I'm drunk already or something. I got the hiccups. And I swear this is just coffee that's in this mug, I promise. So if we are looking at what they call the marginal effects, essentially what that is looking at the averages across these conditions. So, for example, what that means is that if we were interested in looking at the effects of condition, so this is going back to the alcohol and body weight experiment. If we were interested in looking at the effects of condition, we would take the average of placebo and take the average of drunk, and we're going to do what they call collapse across the conditions. So you're going to take, for this, basically 5.09, which is for light men, and 4.72, which is for heavy men. You're going to collapse those together, get the average, which is 4.91, and you're going to do the same thing for the drunk group, and then based on that, you can compare these, and you can say, yes, 6.6 is higher than 4.9. So it looks like there was a difference. There was a main effect of drinking condition. If we are to look at this again for body weight, we would say, yes, there is a main effect here too, because for light men, we see that the average is 5.5, and for heavy men, the average is 5.96. There is a difference there. And so we would say there is a main effect here. So if we are looking here at there is main effects here. The interaction is not super obvious though, right? Not until you diagram it out, not until you chart it out, where you can see how those lines intersect. Here again, looking at this, and I'm not basically using the same kinds of ideas, you can see that there's not really huge effects, right? It doesn't look like there's a main effect of either independent variable, or at least to me it doesn't. 5.56 versus 5.55 and 555 versus 557, those are not really big differences, right? It's not until you graph it out that you can detect, oh, this one doesn't have main effects really, but it does have an interaction. Yep, so basically here again, what we're seeing here is that for that last experiment, there is an interaction where we don't really see that here for the cell phone and young driver example. That these lines are pretty much parallel, and because of that, there's not really an interaction. All right, so you can add as many of these variables as you want. If you want to, you can go nuts and you can just add as many independent variables as you want. But here's the kicker, here's the problem. Well, actually, there's lots of problems if you do this, but the biggest one is that if you want a good experiment and you want to keep adding independent variables, the more independent variables you have, the more participants you need. And you need a lot of you need a lot of participants whenever you start adding up these independent variables. Whenever I'm working with students in research methods 2 and they are designing their own experiments, the thing that I find most common is that people think big. They think they have big ambitions for their research, and they want to look at everything. They want to look at let's say that we're looking at driving, for example. If you wanted to, you could look at different age groups. You could look at teenage drivers, college drivers, postgraduate drivers, and senior drivers, right? So you can have like 4 different conditions of age, and then you could look at whether they have cell phones or don't have cell phones, or whether they're listening to music or not listening to music. You can pack all of that into one experiment. That would be a crazy design. It would be like a 4x2x2 design, which is a monster of an analysis to do, and it would require a lot of participants, because essentially you're going to want to think about the sample size for each of those conditions. You're no longer just thinking about, oh, well, I want 100 participants. You're going to want 100 participants for all of that stuff, right? Which is going to balloon the amount of resources and time that you need for all of this stuff. So if you want more independent variables, you can do that, but it's harder to draw conclusions because of that. Because sometimes these main effects are buried and you have to rely on the interactions, and that is harder to tease out whenever you're using statistics to verify your results. So, like I mentioned, let's add another condition. Let's say you're being ambitious, and now you want to look at young drivers and old drivers, but you want, which you may remember, was basically just a main effect, right? That young were better or faster than older folks, and that when they were on cell phones, the people on cell phones were slower than people who were not on cell phones. So now we're going to have a little bit of a twist. We're going to have basically cell phone, hands-free, and no cell phone. So now we have can you guess what kind of, it's a blank by blank design. So if we have these two, we have a group of two different ages, and then we have an independent variable that has three different levels. That is going to be a 2x3 or a 3x2 design. So if we were to chart this out, you can see that the table is a 3x2 because it has one independent variable that has three levels, and it has one independent variable that has two levels, which is a group. So if we were to do this, we might get results that look like this. And again, for me, whenever I see this, I just see a bunch of numbers. It helps me visualize it, or helps me interpret this by visualizing it. So what do we see here? What we're looking at here is that whenever people are, this is a moment where I wish that we were meeting face to face so that I could just ask you and get your opinion about what it is that we are seeing here. This is some of my favorite stuff in research methods, is looking at data and trying to understand what is the story here. What is it that our experiment has found? Is telling us a story. What is that story? All right, so, and actually I'm going to move up my camera a little bit, I think, if I can. All right, or actually I'm going to move over here. I'm not sure if that's working for your experiment, but, sorry, for your video, but now I'm down in this part. So what we're looking at here on the y-axis is going to be how quickly people can brake, so their reaction time, and then we're looking at these three different conditions: hands-free, handheld, and no phone. So let's just look at young versus old. In this case, pretty much across the board, older drivers are slower at braking than younger drivers. This would probably be a main effect, right? If we got the average of young drivers and we got the average of old drivers, we would see that there is a difference, right? That there is, if we were to collapse across these and get the average across all these conditions, there would be a difference between these groups. But again, that's not the only story. The story is now a little bit more complicated. So if we look at, for example, no phone, what is it that we see? We see a difference. Cool. But if we were to look at hands-free, what do we see? Again, we see, slower reaction times than whenever they are on no phone. But we also, again, look at the difference within the difference. So look at how much these two groups differ, right? Now look at how much they differ over here. Are they the same? No. It looks like here they may differ by, 200 milliseconds. And then whenever we look at the hands-free condition, that now they differ by maybe 300 milliseconds. So what we're looking at here is a main effect, but we're also seeing that there is also another effect, and that effect is an interaction. So that basically, that there is an effect of young drivers, there is an effect of old drivers. That does make a difference. It also makes a difference the kinds of conditions that are basically for all these conditions, that there is a difference between handheld cell phone and no phone. Probably not really much of a difference between handheld cell phone and hands-free cell phone. But we do see that there is an interaction, that young versus old, that basically older folks are going to be much better driving with no phone than they are driving with hands-free cell phones compared to the younger drivers. So the difference between old and young is exacerbated whenever we look at the hands-free condition. Now, why that is up to you. Like if you collected this data, now it's your turn to interpret what it is that you found. The way that I would probably interpret this, honestly, I would say that younger folks are more accustomed to Bluetooth and talking without cell phones, whereas for older folks that might be a little bit more burdensome, might be a little bit harder to do, harder to handle, and maybe that is the reason why that younger folks are a little bit better than whenever they have handheld. But honestly, it's not really that big a difference. And so when we're thinking, about safety concerns, we can see that, yeah, hands-free doesn't really make that much of a difference compared to handheld cell phones when we're driving. All right, so that was a lot of information to unpack. So let me get back over here to my happy place in the top right-hand corner. So in that case, we added another condition. That condition was no cell phone versus hands-free. And if we wanted to, we could go wild. We could even add in traffic conditions, where in this driving simulator we have people that are having light traffic conditions and people that are doing rush hour traffic conditions. And so in this case, if we were to do what we're seeing here, just this information, this is a 2x2x2 factorial design. If we kept the same conditions as the last one and added traffic like that, that would be a 2x3x2 design. Just in case that clears anything up. And so if we keep adding these independent variables, we can do that. It just makes things more complicated. But sometimes sometimes you need that for your particular kind of experiment. So looking at what we were just talking about here, where we have young versus old, and we have cell phone versus no cell phone, and we have light traffic versus heavy traffic. That is a 2x2x2. You can see that kind of up here. Let me move myself. Let me move myself over here so you can still see me. Here, basically, we have light traffic, heavy traffic, and within light traffic, we're going to have hands-free and cell phone and young drivers. So very similar to what we saw at the very beginning of this video. Now we just have two of them, one for light traffic and one for heavy traffic. So if I were to ask you on an exam, is this an interaction or is it a main effect? You would say there is a main effect for heavy traffic. There's an interaction for light traffic, right? How can you tell? Because for heavy traffic, it does basically, these are parallel lines. For light traffic, it makes a difference. Cell phone use makes a difference, but only for a certain condition, right? So let's take a look at what that is. I'm going to start out with heavy traffic because it's a little bit easier to interpret because it is just a main effect. So we see that there is a difference between young drivers and old drivers, right? So yes, age is a main effect. But we also see that there is an effect of hands-free versus cell phone, and for both groups, they're faster for no cell phone use than they are for hands-free cell phone use. So again, another main effect. But now, if we were to look over here, we see that there is an interaction. That basically both groups, whenever they are not on a cell phone, are going to do just as well. So whenever they are under light traffic circumstances, there is no difference in their braking rates. But when they are on a cell phone, there is a difference in their braking rates. That, again, older drivers are slower than younger drivers. So that is an interaction. So this is, and I've talked about why we don't want to do, a factorial design if we can help it. But this is a pretty good case for why sometimes factorial designs can be good, right? Because what this is showing is that we would have missed out on this story if we only stuck to that original 2x2 design. We learned that basically people are worse with cell phones and that they're not as fast whenever they are older. But we would have missed out on this entire thing about light versus heavy traffic, right? And seeing as basically how whenever there's light traffic, that there's basically no difference between age groups. That those differences only occur whenever people are in heavy traffic or whenever they are using a cell phone in light traffic. All right, so again, this makes things look super complicated, but you can kind of look at the different kind of averages for each of these different conditions, and you get the idea. So, in this particular case, we would say that, is there an interaction here? No. Is there an interaction here? Yes, definitely. All right, so that is all that I wanted to talk about for the factorial design. I told you, this is kind of a tricky chapter. Next chapter, we're going to be talking about single subject designs, which I think is much easier than this stuff, and it's a little bit easier to plot out and to interpret and to do things like that. So before I get there, though, I want to talk a little bit about the next research discussion that is due. This particular experiment is about a hormone called oxytocin and how it decreases accuracy of our ability to detect when people are lying. So that's what it means. Let me move myself over again. That's what it means by oxytocin decreasing the accuracy and perception of social deception. Very complicated title, but a very short article. The reason why I'm bringing it up here is because I just want to point out that if you have any trouble understanding some of the basics here, you can check out these videos. These videos are of what's called the prisoner's dilemma. These are fun videos of a game show that are going to show essentially what this experiment's behavioral task is, just kind of in a game show setting. So basically, the people that are in that task are going to be asking to interpret the results of what they see in these kind of videos. Again, for me, I think I'm a little bit. It helps. These things help click for me whenever I see these things in action. So I hope that for some of you that are working on that, if it seems vague or strange what you're reading, check out these videos, and I think that might clear some things up. And hey, we're done with this chapter. I'll see you in the next chapter. Bye.